And welcome back, AP Econ students. Time to go over another free response question from an old AP exam. This question is from the AP Micro exam from 2019. 2019 had two versions, and this is set 1, the other one being set 2. So let's see what they're looking for. Question says, as the only gas station in a small town, they just told you right there it's a monopoly. And then it actually says, Philip, the name of the company, the name of the gas station, has a local monopoly on the sale of gasoline. Philip is currently earning positive economic profit. All right, so in the statement there, you can already determine you're in imperfect competition and you're making a profit. So just very, very quickly, because it's so good to have these down. If you're in imperfect competition, three things can be happening. You can be making money, losing money, or breaking even. And so all of them are going to have your marginal revenue and demand curve. And so you could draw that on all of them. But it all depends on where the ATC is located. So if I'm making money versus breaking even versus losing money. Well, if I'm making money, my ATC has to be lower than my price. So that's not a very good ATC there, but it's low here, and there would be my marginal cost curve. And MR equals MC. I'm not going to do all the values here, but MR equals MC would be here. And you could clearly see that your price that you're receiving is higher than your costs, and this would be a typical profit making. And we'll make a neater version of this in just a second. The other one, when you're breaking even, that's the time when you sketch this one. You draw your marginal cost curve first, because you need to get your MR equals MC value. And that's going to be the spot right there where your ATC comes in and is tangent. So it kisses right there and then does that. And so what you wind up seeing is that your total revenue brought in is equal to your costs. And so this right here, this is the you're breaking even. Okay. And then the last one would be a high ATC. It's well above the demand curve here, the demand price curve. And then you can go ahead and bring in your marginal cost curve. And you would see, well, here's MR equals MC. That would go up to the price. Well, here's how much money you're bringing in right here. But our costs continue up to here. And so this box right here, this would be your loss box right there. Here you're breaking even, and this what I have shaded in. I'll overlap that with PROF for profit. Okay, so you just want to be comfortable just moving your ATC up and down. You think of it that way. You could think of moving the chopsticks up and down, but it's easier for this example just to be thinking of sliding the ATC up and down. So you want to have the three possibilities locked in. And since this one says you are earning a positive economic profit, it's going to be this top one. So we're just going to make a real nice, neat version of this over here. So this is for part A. So we're going to make a nice, neat version here. So I'm going to go ahead and use a straight edge, so we have this nice and clear. And we'll make this good sized. Okay, and there's going to be my demand curve and marginal revenue. I always like to bring marginal revenue all the way down to actually where it goes a little negative, because where marginal revenue is 0 is a very important point. You always want to have that reviewed. In fact, since it just came out, remember, marginal revenue being 0 in all of these, it's a very important point. It divides your graph into the two zones, the elastic zone and the inelastic zone, and it's where total revenue is maximized. Important point there. Okay, and since we're making a profit, I'm going to come down kind of low here. I'm just going to make a target point there for my ATC, and ATC looks just like a quadratic. Got that. And at my ATC minimum, I'm now going to bring in my Nike swoosh marginal cost curve. Okay, and if your marginal cost curve has a little bit of angle this way, it makes the rest of the graph easier to draw. So when you make your marginal cost curve having an angle like that versus having it too upright, more vertical marginal cost curve makes all your intersections a little too close together and kind of cluttered. So having this angle gives some good separation. Okay, now MR equals MC, our most important spot right here. There's your tattoo. profit maximization, and I'm going to go ahead and use my straight edge for that one as well. And I'm going to make a dotted line all the way down. Okay, and use my straight edge to give this value too. So right there's the total revenue, and they're going to wind up asking about total costs as well. So I'm going to put that one there. Okay. All right, so you can see here's M equals MC. So this entire large rectangle, that is the total revenue, because it's the profit maximizing quantity times the price. So how many things are you selling times the price? That'll give you your total revenue. And since our price is higher than our costs, we have a nice little profit box here, and here would be our costs here. Now just to finish this off, we've got our quantity axis, and we've got our price axis, and I think we're all good. So I've already actually answered some of the questions that are coming up, but let's go through here now. So it says, draw a correctly labeled graph for Philip and show each of the following. Philip's profit maximizing quantity, or our tattoo, as Q sub F. So this will be right here. It's a Q and the subscript is F. It's a quantity value, that's why it's Q. Profit maximizing price at P sub F. So that was all the way up here, and that value here is on the price axis, and that's why it is capital P sub F. Number 3, the deadweight loss associated with Philip's profit maximizing quantity shaded completely. Now, brief pause right here, because I want to go, actually I'm going to get rid of these guys. I want to go back to a little concept here. Some students get a little confused when it's deadweight loss in imperfect competition, because most of us are comfortable with deadweight loss when we have nice, clean, and straight supply and demand in a more simple graph. And if we, let's say we had a price floor or price ceiling or something in here, or even a tax, most of you are used to seeing a deadweight loss show up in this nice little triangle right here. And you'd say, oh yeah, there's my deadweight loss. And just for this example, let's pretend it was a deadweight loss as a result of a price ceiling having an effect. And the question would have been, price ceiling goes in here, here's our extended consumer surplus, here's our producer surplus. Just to give you an example, different context here, but you're used to seeing this little deadweight loss right triangle. Or not right triangle, but deadweight loss triangle here. The other times it can show up, it could have been, well, maybe it was a tax. Maybe this was S plus tax, and you were doing your tax revenue box. And you had small consumer surplus, and this was divided in two. It could have been something like that. But we're frequently used to seeing this nice little deadweight loss triangle. Well, it's the same idea. You just have some other things in the way that I want to point out. And the other thing is, remember, your marginal cost curve is equal to your supply curve. Those are the same thing as long as you're above your ABC minimum. So I want you to look at this slightly different and just pretend the ATC was not there. If the ATC was not there, we would have this picture. Take that out of the way. If the ATC was not in the way, we'd have our demand, our marginal revenue curve, and I'm going to go ahead and bring in our marginal cost curve. Okay, so no ATC. Just to show you how clean this could be. MR equals MC would still be our profit maximizing quantity. Okay, and we would still go up here. And right there we made there's our deadweight loss triangle. It's right here. It is still the triangle that's made between the supply curve, whatever this point is that is having us elevate, to the demand curve. Because remember, this is where that's actually society's optimal, where supply equals demand. That's a really special spot. And whenever we're not there, we're creating some sort of inefficiency. So this inefficiency was created by imperfect competition, where we had marginal revenue. And so this deadweight loss triangle is just right here. Very similar to earlier when you were used to this deadweight loss being this nice little triangle right there. It's the same idea. The only thing that's confusing, ATC is in the way, and marginal cost does have curvature to it in the part that's actually not supply curve. So if you look in right here, there is our triangle. Okay, and again, pretend the ATC is not there. So I'm just going to shade that in. Okay. That is our deadweight loss triangle. All right, and then it says, find the maximum quantity at which Philip would earn 0 economic profit. Well, 0 economic profit is going to be when your price is equal to your costs. So when does the price equal the cost? Well, this is my demand and price axis. There's my ATC. Those intersect right there. So at that spot right there, and they're asking us to call that Q sub Z. Get the marginal revenue curve out of the way. Drop that down a little bit. I'm going to call that Q sub Z. Okay? All right, where my costs equal my price, right there. All right, and make sure that you're always putting these along the axis. Don't go up here in the actual area of the where the graph is occurring. You want it to be along the axes if they ask for something. Okay, so there is 1 through 4 on part 1. All right, time for part B. Part B says, start up here. Part B says, assume that Philip's fixed costs increase because of a new lease on its property, and Philip stays in business. Will each of the following increase, decrease, or remain unchanged at Philip's profit maximizing quantity? All right, so the question is, what kind of costs change if it's a fixed cost change? So your rent just went up. So if you can imagine this graph right here, what's going to happen if all of a sudden we have some unexpected costs? Now, remember, there's a difference between our variable costs and our fixed costs. If they would have said, there's a new law passed and all employees have to get an increased salary or increased raise or minimum wage went up or something like that. When your variable costs change, so I'm just going to say a change in variable costs versus when you have a change in your fixed costs. You have to understand how that's going to affect the graph. If your variable costs change, this is going to result in a marginal cost change. If your fixed costs change, that's going to result in an ATC change. Okay? And so that's what they're testing you on. So you just say, okay, well, my fixed costs are going to change. That means that my ATC, my costs are higher. That means, if you can imagine on this graph, my costs are going to go up. Nothing else changes. So if just my costs elevate, I'm going to eat away at my profit. I'm not going to be making as much money. But there was no change on demand. There was no change on my marginal revenue. There was no change on my marginal costs, because my marginal costs are not affected by fixed costs. They're in different categories, and that's what they're testing you on here. So just for the sake of looking at this, I'll put this down here. Okay, so here is what we are looking at. So if this is the situation right now, okay, and there's your profit box, okay, and so we just had an increase in our fixed costs, which affects the ATC. I'm going to do this in red. I'm going to make a new ATC. Well, my ATC elevated. Well, if my ATC elevated, and keep my minimum, I'll just do a modest increase here. If my costs went up, just relatively modestly, and there's my new ATC in red, and we redo this question, notice how MRM equals MC didn't change. That's still right here. But what winds up happening is, look how much smaller my profit box is, because now this is where my profit would be. My costs are much higher. So this is what they're testing you on. So if you have time, as much as you would like, you can always be sketching other pictures here to help you figure this out. So what it asks, now the other question it asks too, if you guys can see on this, as my ATC goes up and down, notice how my profit maximizing quantity, or what they're actually looking for in this question, I'm going to do this in green. If you can see in this picture right here, here is my deadweight loss triangle right there. And remember, the ATC, in fact, when I first sketched this over here, I said pretend the ATC was not there. Then you can see the deadweight loss triangle pop pretty nicely. So here's your first question on B. So it says, assume the costs increase, there's a new lease, new fixed costs go up. Which of the following will increase, decrease, or remain the same? So what's going to happen to the deadweight loss? Well, in this picture, you can see the ATC going up and down. The ATC wasn't even relevant to making the deadweight loss. So there's no change. So it remains unchanged, and then we have to explain why. And so we will say, this is up here, I'm just going to say DWL. DWL remains unchanged. Now, if my marginal cost curve would have changed, the marginal cost curve would have affected the intersection point and would have made a different one. But on your explanation, this sounds a little bit incomplete, but it actually is fine. Because they're having you differentiate between variable cost changes and fixed cost changes, you can just say changes in fixed costs do not affect marginal cost. And the reason why that's important is marginal cost is one of the sides of the triangle, of the dead weight loss triangle. So you're pointing out that if marginal cost was changing, that's a side to the triangle. ATC doesn't even make a side to the triangle. So dead weight loss remains unchanged. Changes in fixed cost do not affect marginal cost. And that's what they're wanting you to point out. Okay, and that was question 1, right? Okay, question 2. Philip's economic profit. Well, that definitely went down. We just illustrated it with this. And we don't even have to explain. That actually would have been a better question for an explanation. But that's definitely going to decrease. Okay, economic profit will decrease because costs are higher. All right, now it's time for C. C says, assume the demand for gasoline increases because people bike to work more often. Okay, what must be true for Philip to continue to operate in the short run? Okay, now sometimes you'll get questions, and this is why it's so important to go over the old AP exams, is sometimes you get a question where, especially when you're smart kids, you could answer that question lots of ways, and you're thinking, boy, that's kind of vague. And oftentimes the question is kind of vague, but they're wanting it to be in the context of an AP test, in the context of micro, and in the context of this scenario here, what must be true. And so it's easy to miss this question if you don't realize where they're kind of pointing you to. What they're pointing you to is to continue to operate. They're trying to drive you toward the shutdown price, which is the average variable cost curve. And so I'm going to actually just sketch that. It sometimes just can kind of sneak up on you. They used to stress it a little bit more. But if you remember, when you first started learning about cost curves, you had your average fixed costs, which would decrease, and then you had your average variable costs, and then you had your average total costs, and then we had our marginal cost that was going to catch these minimums. Didn't draw that very well. But we had a marginal cost, we had our average total costs, we had our average variable costs, and we had our average fixed costs. And then we talked about how, and again, I'm not drawing this very well, but we talked about how this was never going to be on there. And you would, oftentimes the AVC is not on there. But this little point right here was really important. This is called the shutdown point. And it's called the shutdown point because if your revenues ever come down to the point where you're at the shutdown point, that's what you do. So if I were to insert in here Mr. DARP, just for example, if Mr. DARP goes down to here, you shut down. Now, technically speaking, you could say, well, you could shut down or you could stay open, but you're just covering your variable cost, which is your labor. But the rule is you stay open as long as your price is above the shutdown point, because this will cover your variable costs. This distance here is just going to be your fixed costs between here and your costs, or here in the intersection of the ATC. So, for example, let's just say this was Mr. DARP and we were in perfect competition. We'd say, well, here's MR equals MC. This is what your rectangle would look like. You'd say, well, here's my total revenue. Here's the costs right here, or here's how much money I'm losing. So you are losing this much money. You're covering this. Well, this distance right here, if you recall, is the same as your fixed costs. The distance between your ATC and your AVC times the quantity is always going to be equal to your fixed costs. Your fixed costs never change, and that would be there. So if you're like, well, this is my fixed costs, The reason it's called the shutdown point is whether you're open or not, you have costs. And the shutdown point lets you know, you want to stay open? Okay, well, you're losing money. Or you close. You're still losing this much money because this is your fixed cost total. And so do you want to stay open and have wear and tear on your business and all the equipment? Or do you want to just close and you'll lose the same amount of money? So that's what that's called. So that's why in a question, even though you're losing money, as long as you're above your AVC, you will stay open. So just to contrast that real quick. So I'm going to go back to imperfect competition. That's losing money. So this would be imperfect competition losing money, and you would say, well, here's MR equals MC, and you would look at that, and you'd say, well, here is our total revenue. There's that rectangle. But then going up to here, here is our costs. Okay, and this little skinny guy up here, you would say, well, right here, this is how much money you're losing. And so that frequent question earlier in the year is, well, why do you stay open if you're losing money? Well, the reason you stay open is that you're still covering your variable costs. So I'm going to draw that in here now. I'm going to do that in red. Pretend your variable cost curve did something like this. There's your shutdown point right there. And there's your average variable cost curve. And you would look at this and you would say, well, at profit maximizing quantity right here, by being open, you're making more money than you would if you closed. Because if your fixed cost is between the two curves and over, it would be that rectangle. But you can see, as long as you're above your AVC, yes, you're still losing money, but you're losing more if you wouldn't open at all. So it's whether or not your MR equals MC quantity is above AVC. So that is the situation they're leading you toward. This is what they're saying on this question. They're saying is, what must be true if Philip continues to operate in the short run? Well, this must be true. The price they're getting is still above the shutdown price. That's what they're guiding you toward on this one. So you could say price must be above, if you want, you could have an inequality statement, must be above the shutdown price. Now, just because we're on this little question here, maybe they would have said this. What must be true if Philip closes down? You would say, oh, the price must have dropped below the shutdown price. That would have been simple. And if on this one I would have drawn my ABC really high, and it was I'm losing more money being open than being closed, that would be the example. Okay, part 2. So that was 1. And then here is 2. And again, all of those graphs, if you go back into the PowerPoints from earlier in the year, you'll see those graphs, and there's lots of really good examples. Part 2 says, what happens to Philip's profit maximizing quantity and price in the short run, assuming the firm continues to operate? So if you continue to operate the profit maximizing quantity, let's go to, might have to draw a new graph, or maybe we can use this one. But if there's a decrease in demand, that is going to be changing. Not only is the demand curve going to move, but the marginal revenue curve is going to move. And so, yeah, I think it'll probably just be easiest to sketch that real briefly here. So what's going to happen to that quantity? And a lot of you guys, I know you can totally imagine that and see this here, but I just want to be really thorough here for anybody. If and the graphs get really messy when you start shifting these. So if here's our demand and our marginal revenue, and I'm just going to draw my marginal cost curve. Okay? Because what it says is what happens to Philip's profit maximizing quantity. So, in other words, what happens to that point right there if there is a decrease in demand for gasoline because people are riding their bikes more? Well, if there's a decrease in demand, that's real simple. This is going to move that way. Well, if that's going to move that way, so is the marginal revenue curve. So I'm going to draw that actually in red. My decrease in demand means my chopsticks move over. So now here's my chopsticks. Say there's my demand, and here's my marginal revenue. They both moved that way. Well, now here's MR equals MC. It's right there. So what should be clear to see is what happened to this point? Well, here's my new profit maximizing quantity right there. All right, so what happened to it? Well, clearly you can see it went down. Okay, it went down. And you can also see what happened to the price. Well, the price clearly went down too. Okay. So the price and quantity both decrease. So it says what happens to Phillips' profit maximizing quantity and price in the short run because of the decrease in demand. And so this was no different, by the way, way earlier in the year. This was like when we were first just beginners shifting supply and demand. This is a shift in demand going that way. So demand shifts left. What happened? Price decreased, quantity decreased. That's all this was. Okay. So the answer here is both price and quantity decrease. Okay. And that is question number 1. Now, obviously, as I'm going through these, I'm explaining a lot, and I'm going off on little tangents, discussing concepts and all of that. But you can just plow right through this, and this is a 10-minute question, 5 to 10-minute question. So feel free there, obviously, to just fast forward to what you need to get to, and if you need the review notes, great. And if it triggers a thought that there's a concept you don't know very well, just head back to the PowerPoints and you'll know you got to review certain sections. So the AP questions are really, really great for the review, seeing where you've got some weaknesses. So that is question number 1. Time now to move to question 2. Okay, question number 2 says, the following is a table showing Dana's marginal benefit from purchasing bottles of water and good X from a grocery store. Well, once again, you would have thought they could have come up with a product other than good X, but that's the creativity of the College Board on the econ exam. So, looks like we have here, it looks pretty straightforward. We have the bottles of water, and the thing you want to notice, don't get tricked by this. They're giving you the marginal benefit. If you go back to another AP exam, they will list the total benefit, and you have to calculate the marginal benefit. So when they give you one of them, they always ask about the other. So we're going to have to do something to total benefit. It's just part of the way it works. The one they give you, they ask about the other. So we're going to have some total benefit questions here, I can tell, because they gave us marginal. And so the quantity of water bottles, as you consume more, you can see the marginal benefits going down. And then for good X, whatever that is, you notice very quickly they have absolutely identical marginal benefit curves. Or marginal benefit, I should say, tables. So that's kind of strange. Now, the one thing I need to point out, it's such an easy mistake to make on these, and it's the only way you would know this is by doing them, is what many students misunderstand on this is that they're doing the marginal benefit in the of the first bottle is 24. The marginal benefit of the second bottle is 28. What you don't want to do is think, oh, the quantity of water bottles, there's 2 of them, and I had 2 of them, and each one was 18, so it's a total of 36. It's not like that. What this is meaning, the way this is listed, is they're giving you the marginal benefit of that particular bottle consumption. So obviously, when you get to the 5th bottle, the marginal benefit of just that 5th bottle is only 3. It's all diminishing. That's important clarification. You can make a silly mistake otherwise. So these 2 tables right here, I have enlarged right here, so we can see it's a little easier and play with them. So the question says, what is Dana's total benefit from purchasing 2 bottles of water and 1 unit of good X? Okay, so 2 bottles of water. This goes to what I was just saying about how to read these. What you don't want to do is say, oh, 2 bottles of water, 2 times 18. That's what they're trying to trap you into doing. You want to say, well, the first bottle was 24, and it said she had 2 bottles, so the second one was 18. And then there was 1 unit of good X, and that was also 24. So this is actually the list you're looking for. All right, so it's 24 plus 18 plus 24, and that is equal to 66. All right, so that was just a little quiz on, or a little test on, did you know how to read this? Because some students, instead of doing 24 and 18, obviously these 2 together here, that's giving you, 42? Versus just doing 2 times 18. Easy mistake to make. All right, question B. Assume that the price of a unit of good X is $5. All right, so this thing is $5. and calculate the total consumer surplus if Dana purchases 3 units of good X. Show your work. Okay, so let's see what the total benefit here is going to be from purchasing 3 units. So what I'm going to say is it looks like it's going to be 24, and then you're going to add an 18, and then you're going to add a 12. So that's going to be the total benefit. So this is 30 plus that's 54. So she's got $54 worth of benefit right here. Okay, which by the way, back over here if you wanted, probably wouldn't be a bad idea to put $66 there. Probably be fine either way. Okay, and then so we have $54 of benefit. Now, it's really important you read carefully here. It says, assume the price is $5, calculate the total consumer surplus. So when you hear consumer surplus, you want to be thinking back into supply and demand. What we're figuring out is this area right here. Okay, what is the consumer surplus versus the producer surplus? Well, this right here is not the consumer surplus. This is actually the total surplus. What we have to subtract from it was the producer surplus, or the cost to actually purchasing these. Well, she purchased 3 of these, and so the cost for 3 of them was 5 times 3, which is equal to 15. So you have to subtract the cost from the benefit to get the total. Okay, so it's 54 minus 15, or 39 you would get. So it says here to show your work. I'm just going to recopy that here. I'm going to say, well, I had 24 plus 18 plus 12, and that was the $54 of benefit. Then it was going to be $54 minus 15, which was the cost, and that was equal to $39. Okay, $39 of total total consumer surplus. Okay. All right. So just a clarifier here as well. When you do consumer surplus on the graph, if you remember, to figure out what this distance is right here, you're always subtracting off this amount. But when we do it in a table, we don't have anything to subtract yet. We have to do it afterward and subtract off the 15. That's why that's where that's coming from. All right, now let's do part C. Part C says, now assume the price of a bottle of water is 3. So I'm going to come back over here. And this was the question I was anticipating, was marginal utility per dollar, and trying to figure out what combination would both work based on your budget. So it says, all right, assume a bottle of water is $3. Okay, so this is $3, and good X is $6. Okay. Dana spends her entire budget of $30 on bottles of water and good X. Explain why she doesn't maximize blah, blah. Well, before we go to that, what we're going to do is just, because we have our margin utility, we want to do margin utility per dollar. And so what I need to do is divide the benefit, or the utility here, by the price, and I'm going to get margin utility per dollar. So what I'm going to do right here, I think it'd probably be best, I think it'll work right here. I'm just going to insert right here a vertical line, and then right here I'm just going to put MU divided by a $sign, and I'm going to do that over here as well. Okay, and so that'll be margin utility per dollar. Now on these I'm going to divide by 3 to get my margin utility per dollar, and on these I'll divide by 6. So divided by 3, it looks like I get 8. Divided by 3, I get 6, 4, 2, 1. Very friendly. And then over here I'm getting 4, 3, 2, 1 and a half. Okay? Now if you remember, if you want to maximize utility, you equate margin utility per dollar. And if you look here, we've got 86421, and here we have 4321. It looks like we have, we have 3 places where the margin utility per dollars are the same. So it looks like right here, they are both 1. We have that combination. It also occurs here that they're both 2 at that combination. Okay, and they're both 4. I'm going to put an open circle there. Here, that's not a 40, that's just an open circle there, okay? All right, and so I have to investigate both of those, or all 3 of those, I should say, okay? So let's go ahead and write those down. It looks like when they are both 4. So when the margin of utility per dollar is equal to 4. All right? I'm going to write that equation. So when they're both equal to 4, it looks like I would use 3 water bottles. So I'm going to do 3W plus, over here I would have 1 good X. And we'll figure that one out. When the margin utility per dollar is equal to, when the next time the same is 2, we'll write down that equation. Well, when it's 2, you're having 4 water bottles. And when it's 2 over here, you're having 3 of good X. Okay. And then when the margin utility per dollar is equal to 1, we're having 5 water bottles plus 4 of good X. All right. And now we're going to say, okay, well, what did that cost? Well, these were $3 and these were $6. So in this situation, this would lead to 9 plus 6, which would equal $15. Okay. This one right here, 4 times 3 is 12. 3 times 6 is 18. And that would equal $30. And our last one here, 5 times 3 is 15. 4 times 6 is 24. And we are getting $39. Okay. Now the question says her budget's $30, so it's going to be this middle one here. This is the one that's going to maximize utility based on this question so far. But we haven't really even addressed any of the specific questions yet. I could just see this coming, so we got this out of the way. All right, so now let's go ahead and read this. It says, explain why Dana does not maximize her benefit when she purchases 2 bottles of water and 4 units of good X. Well, when she purchases 2 water bottles, her margin utility per dollar is 6. And when she purchases 4 units of good X, her margin utility per dollar is 1. Her margin utilities per dollars do not equal. That's what they're looking for. So when they say use marginal analysis, explain why it does not maximize your utility. All you have to say is the marginal utility per dollar is not equal. And you can say the first one, it was good, 2 bottles of water. You can just say 6 does not equal, because that was our margin utility per dollar. And for good 4 of these, it says, does not equal 1. Okay, and that'll communicate that you were reading this. Okay, they're not equal. That's a very concise and very adequate explanation. Part 2, it says, what are the optimal quantity at these prices? Well, I could see that coming, so that's why we did this. So we just have to copy that there, and we just say 4 water bottles, or 4 waters and 3 of good X. Okay. Number 3 says, now suppose the unit of good X drops to $3. Calculate Dana's cross-price elasticity of demand for water bottles with respect to the price of good X and state whether the 2 goods are substitutes or complements. Okay. Well, what I'm going to do on this one, I'm going to go up here and I'm going to say, okay, well now what if this one was $3? How would that affect things? Well, if this was $3 instead of 6, both of these things would be identical. And so I'm going to do this column right here. If this would have been worth $3 over here, okay, then this would I'm just going to completely copy what I have over here. This would go down. It would be 8, 6, 4, 2, and 1. And if you'll notice, we would have, you want to equate your margin utility per dollar is the same. You'd say, oh, well, we would do 1 and 1, 2 and 2, 3 and 3. Because the same way we got these, they were staggered because the prices were different. But now when the prices are the same, look at all the options we have. And I'll switch this here to red. So what my choices would be when my margin utilities per dollar are the same, I actually have 5 options. So if I said margin utility per dollar, now what I'm about to write, for many of you, this is totally not necessary. I want to very thoroughly explain this so I don't lose anybody. But a lot of you guys could see exactly what's going to happen and be done with this in literally 10 seconds. But I just want to fully explain it. So your marginal utility per dollar, when they were both equal to 8, that happens. The marginal utility per dollar is equal to 6. Marginal utility per dollar is equal to 4. Marginal utility per dollar is equal to 2. And the marginal utility per dollar is equal to 1. So these are all 5 scenarios that actually work. Well, the nice thing is this is really easy to set up now. That would be 1 water plus 1 of good X. Then this one is 2 waters plus 2 of good X. 3 waters plus 3 of good X. 4 waters plus 4 of good X. 5 waters plus 5 of good X. Okay? And then you can say, well, what's that going to lead to as far as price? Well, we can knock that out pretty quickly, too. They're both $3 here, so this would be $6, right? Just one of each, so that would cost you $6. And this would be 2 each, so 6 and 6, this will be $12. And 9 and 9, right? So 3 times 3 is 9, so 9 plus 9, this would be $18. And the next one would be 12 and 12, so that would be $24. And the last one would be 15 and 15, and that would be $30. Okay? Now, if you remember back on the problem, her budget is $30, so look what happened. Wow, she bought more of both things when the price dropped. Okay? So, the reason I took time to show you that is now let's read the question. It says, suppose the price of unit X drops to 3. Calculate the cross-price elasticity of demand for bottles of water with respect to good X and state whether the two goods are substitutes or complements. Well, why did I just redo this? To show you on the cross-price elasticity how doing what I just did would be, in case you couldn't see through this in your head, I wanted to do this part. This part I know a lot of you just did in your head. But now it's actually the question is about cross-price elasticity. So if you remember, cross-price elasticity tells you about whether goods are complements or substitutes. Okay, that's the whole point of cross-price elasticity. So when CPE is a positive number, so when it's greater than 0, your conclusion is they are substitutes, and when cross-price elasticity is a negative number, you have complements. Okay, so way back earlier in the year, it was mountain bikes and helmets, or bikes and bike helmets. We've had this example has come a few times. Milk and cookies. You go into the store when the complement's on sale. When cookies are on sale, you buy more milk. When the price is raised, you buy less milk. Things that go together. When one price drops, you buy more of the other, and that tells you if they're complements. But if one price goes up, it tells you they're substitutes. So when the price of Coke goes up, you buy Pepsi. A price rise makes you buy more of the other, whereas a complement goes down, you buy more. That's why they're opposites there. So the question says, well, what can we figure out? Can we calculate this and figure out which one this is? So here's what we get. Here's the formula now. If you make sure you have this memorized, cross-price elasticity formula is going to be, price goes on the bottom still, but remember, it's percentage change. Okay, percentage change in the quantity of one good, so I'm going to say of quantity of good A, over the percentage change in price of good B. And it all depends on what information you're given to figure this out. You can figure it out both ways. They usually only give you information about one item versus the other. So I'm going to move this over here and see if we can figure this out now. All right, so for our situation, cross-price elasticity of demand, let's see what we've got here. So the price, they told us about the price here, that the price dropped to $3. Well, dropping from $6 to $3, that's a 50% decrease. So I'm going to say this dropped by 50%, but I'm just going to do decimal. So I'm going to say this dropped by 0.5. So it was negative 0.5. Okay? And so now we have to figure out, well, what was the change in quantity for product B? So for our example, our denominator is good X. Our numerator is going to be the water. Well, that is why I did this whole thing, to show you guys what changed. I want you guys to look at what happened because of the price drop. Because of the price drop in the good X to $3, look what wound up happening. We actually increased how much of the water bottles we bought. We increased from 4 to 5. Therefore, if it's an increase, that tells me my numerator is a positive number. I don't even care what it is, but it's actually pretty easy math here. If you bought 4 and now you have 5, that's a 25% increase. It's a quarter more. So this would be a positive 0.25. But that, again, that's a negative number. Well, if they're negative numbers, that tells me that these things are complements. So this number, cross price elasticity, is 0.25 over negative 0.5, and that is less than 0. So my conclusion is they are complements. Okay. Now, once again, all of this stuff I did, I know a lot of you guys could have zeroed in very quickly and just noticed that, and you would have just said, oh, if this is $3, what's going to happen? Oh, well, these two things are the same, and you could have just looked at it and went, oh, well, you're going to buy 15, oh, you're going to buy 5 of each. This one went up, and you figured it out very quickly. But again, I just did this for the sake of thoroughness here. So this right here, all of that is your answer here for number 3. Okay? So a marginal benefit table and calculating, woven there, cross-price elasticity and figuring out maximizing utility. There it is, question 2. One more left, number 3 coming up. All right, question number 3 very obviously jumps out at you that it is a payoff matrix. So looks like they've been definitely emphasizing this in the last couple years. So you want to make sure you are very solid on your skills of how to read a payoff matrix. And I'll read the intro, but then we'll skip all the questions and just figure out strategies, dominant strategies and such, and then we'll go back to the question. So it says, Patrick's Pie is currently the only pizzeria in College Town. It can either advertise or not advertise. Dee's Pizzeria is contemplating whether to enter or stay out of the College Town market. Each pizza establishment independently and simultaneously makes its decision. The payoff matrix above shows the profits for each combination of decisions, and both players have complete information. The first entries in the payoff matrix are Patrick's profit, and the second entries are Dee's profit. Okay, so the first thing we want to do, just to make this thing easier to read, is go through here and let's highlight the left side. So Patrick's Pie is going to be the entries on the left side of the matrix. All right. And it's about whether to advertise or not. And then I'm just going to underline Dee's Pizzeria here in red, and there she's trying to decide whether or not to even enter this market. And if you have 2 highlighters or colors here, just makes it easier to read, and you don't make a careless error. All right, and so regardless of the rest of the questions, let's just figure out dominant strategy. We're going to have to figure that out. So what we're going to do is figure out whether D has a dominant strategy or not. So we're going to force Patrick's Pie to make a decision. So I'm just going to say Patrick's Pie, we're going to force him to make a decision, and his decision is going to be to not advertise. So I'm just going to say NA for not advertise. So if Pat does not advertise, we're down here. Let's see what's better for Dee's Pizzeria. Dee's Pizzeria should enter the market. They'll make 15. 15 is better than 0. So I'm going to say D will enter. Okay. Now let's see what happens if we force Patrick's Pies to advertise. So I'm just going to put advertise, AD. What would be better for Dee's? So now we are in the top row. What's better for Dee's Pizzeria? Well, if they enter, they lose $2. If they stay out, they make 0. It's better to stay out. So I'm going to put D, just SO for stay out. Okay. So clearly D does not have a dominant strategy, because in one situation they enter, in the other situation they stay out. So my conclusion here is no dominant strategy. No dominant strategy, and this is for D's. Okay. Now let's jump over and see if Patrick's Pie has a dominant strategy. So let's force D to make a decision. All right. So now we're going to say, let's make D stay out. So D stays out of the industry. Okay, stays out of College Town. So D stays out. So it's going to be this column. D stays out. What is better for Patrick's Pie? If D stays out, it's better for Patrick's Pie to advertise, because 175 is better than 100. So I'm going to say Pat should advertise. So Pat should advertise there. So then under this, let's force D to make the other decision. So what if D decides to enter? Okay, so D enters. We're in this column. What's better for Patrick's pie? 50 or 150 is better than 50, so do not advertise. So I'm going to say Pat should not advertise. Okay. So let's see. For Pat, in one situation he advertises, and the other he does not advertise. So Pat has no dominant strategy. Well, this is unusual. This happens, but it's a little unusual on this one. There's no dominant strategy for either. And so when there's no dominant strategy for either, sometimes you're taught there's no Nash equilibrium, and other times you're taught that there's two of them. The way our curriculum works, AP Micro, you're taught that there's actually equilibria, plural of equilibrium. You have two equilibriums, and it's just going to depend. And so what will happen is, if we look at this and we say, okay, well, what if Patrick's pie decides to advertise? If they advertise, and it doesn't matter which one you pick here, but if they advertise, since one of these is going to be better than the other, advertising would force D's Pizzeria here to stay out. So this is one of the equilibriums, is that one. And then if they do not advertise, what's better? 15. So we have these two. These two are the two Nash equilibriums. Now you could have figured it out the other way. So in case you're concerned, what if you said, all right, I'm going to force D's to stay out. What's better for Patrick's pie? To advertise. Well, we figured that out the other way. What if D's enters? What's better for them? 150 is better than 50 would be this one. So whichever, when you don't have a dominant strategy and you have to figure out the two Nash equilibriums, it doesn't matter. Just do one of them and the other one will confirm the quadrant you should be in. And so what turns out is that this is one of the Nash equilibriums, is this one, and this is the other one. Okay, so we have two. Okay, now let's go back to the question. Let's see what they ask. It says, what actions maximize the combined total profits for Patrick's pie and D's? So combined profits, well, that's a little bit different. So I think I will... I think I'll put these in blue. So I'm just going to add the two of them together here. So this would be 48. This would be 175. This would be 165. And this would be 100. Okay? Interesting. So the best one for combined profits is actually this one up here. So I'm just going to put a little star right there. It was interesting that they asked about combined profits. They don't always do that, but they did on this one. So what action maximizes the combined total profits? It would be for Patrick's pie, for Patrick's to advertise, and D's to stay out. Okay. Next one, B. Conditional on your response to Part A, does either Patrick's Pie or D's Pizzeria have an incentive to cheat on this combination of actions that maximize the combined total profits? Explain using numbers from the matrix. Okay, so this is a little bit, could be a little bit confusing to explain. But if this is what they decide to do, okay, this one right here, they say, hey, let's we combine our profits, we make a total of 175. Well, D's Pizzeria stays out. So cheating would be, would they have an incentive to get into this marketplace? And if you look at it, you say, well, if I'm D's Pizzeria, what would happen if I don't tell them, but I enter the market? Well, if this is what's going to happen, this one right here, Patrick's Pie is advertising. So what's going to happen if instead of staying out they enter? They would lose $2. So does D's Pizzeria have an incentive to cheat and go from making nothing to making negative $2? No. They're incentivized actually to keep the deal because Patrick's Pie is going to advertise. So you can't even go down here because they're advertising. So which one's better? Right here is better for D's Pizza. They don't have an incentive to cheat because they'll lose money. Now, does Patrick's Pie have an incentive to cheat? Well, if D's Pizzeria is going to stay out, their advertising, their incentive to cheat would be to not advertise. So let's see what happens. If they don't advertise, they would drop from 175 to 100. So they don't have an incentive to cheat either. So both of them have an incentive to stay right where they are because they would lose more money if they were to leave. So on our answer here, we would say for D's Pizzeria, for D's, we would say D's does not have an incentive to cheat. And the reason is $0 is better than -$2. Okay? Or if you wanted, you could just say 0 is greater than -2. Now, Patrick's. Patrick's does not have an incentive to cheat. And the reason, $175 is better than 100. And you can put is greater than or is better. I'll just put is better. Is better than 100. Now, the important part about putting the second number that it's better than is it tells them that you know how to read this. That I'm comparing 175 to 100. This is where he would go to cheat for Patrick's Pie, and this is where D's would go to cheat. So that's why it was important to put the other number. Okay, so part C. Part C says, does Patrick have a dominant strategy? We did all of that work, and they do not. We don't have to explain anything, we just have to answer it. D says, identify the Nash equilibrium or equilibria actions for this game. We talked about that earlier here. So there are two. The equilibria are Patrick's does not advertise, and D's enters. So there's the first one, and the second one is Patrick's we're at here. Patrick's advertises. And D's stays out. Okay. And we got the two. So I wanted to make sure I said they were both. All right, let's move over here to E. That right here. It says, ignoring antitrust considerations, suppose that Patrick pays D's Pizzeria $20 if he chooses to stay out. So you're paying your competition to stay away. Again, the reason it says ignoring antitrust is that you can't do that. Redraw this matrix, including players' actions, payoffs, So redraw the matrix. All right, so what I'm going to do, I'm not going to put all of the values on here. I'm just going to draw the matrix itself. And we'll see if we can adjust everything. All right. So, it says that Patrick's going to pay D $20 to stay out. Okay, so if we go to the stay out ones where he was making no money, he's going to pay him to $20. So instead of 0, he'll make 20. That would be a pretty big incentive. And so to increase that $20, here's the part you want to be careful of. If he's going to pay him $20, it's going to cost him $20, so his profits go down. So in the stay out column here, I want to look right here, 175 goes down to 155 because it's costing him money, and then the $20 goes to D's. Same down here, this drops to $80, and he gives the $20 here to D's. Okay? And then over here, nothing changed over here. It was only this little thing happened if he stayed out. So these two stay the same. So we have 50 and -2. really need the $sign, but we'll put it there. And then this did not change either, so it was still $150 and $15. Okay, so we have a new matrix, and we probably have to now do this all over again. So it says, redraw the matrix, including the player's actions and payoffs, showing how Patrick's pi payment to D affected the payoffs. So we did. There it is. All right, and if you're concerned, you can always you can label everything here. Here's enter. Here's stay out. This is D's. And this was to advertise, this was to not advertise, and this was Patrick's. I'll just put Pat's. Okay. All right, and it says, identify the Nash equilibrium for the redrawn matrix. So again, we have to do this all over again here. We'll just dive in. I think, again, just to make this a little easier to read now that it's adjusted, I'm going to make all of those underlined. Okay, going with D's, and I'll go with blue over here. 50, 150, 80, 155, and that is Pat's. All right, make it slightly easier to read, and let's see what's going on. All right, so let's force Pat. I'll just recopy what I have up here. Okay, so let's Pat does not advertise. Okay, so we're down here. Okay, so what's better for D? $20 or 15? $20 is better, so it's better for D to stay out. So in this situation, D should stay out. Okay, now let's force Pat to advertise. Okay, so it's the top row. What's better? Well, 20 is better than -2, so D should stay out. So D has a dominant strategy to stay out. $20 is better than any of the situations. All right, now let's force D to make a decision. So we will say dominant strategy for D stay out. All right, so now we're going to force D to stay out. And let's see what's better. So we're in this column here. What is better for Patrick? Patrick should advertise. 155 is better than 80. So Patrick should advertise. All right, so now let's force D to enter. So now we're in this one. If D enters, what should Patch do? He should not advertise and make 150. Okay, so no dominant strategy. No dominant strategy for Patrick. Okay. So what's going to happen then? Well, we're going to do the dominant strategy here for D. He's not going to advertise, or sorry, D is going to stay out. So we're here. Okay, dominant strategy, and then we just say, well, what's better for Patrick's? Well, clearly 150 is better than 80, so it's going to be this one. Okay, so there is our Nash equilibrium. So this was, I'm going to do, E1 was right here to actually just draw the thing. And then 2 right here, I'm going to put it there. Nash equilibrium is for Patrick. Patrick should advertise. And yeah, let's just move that over. Patrick should advertise, and these should stay out. Okay, which is that quadrant there. And that is, again, another payoff matrix. Actually, what they've been doing is the payoff matrix wind up being 2 payoff matrix, so you really get to practice this. And so, since that was 2019, probably a decent chance you'll see that in 2020. But we'll see. So there it is, 2019 1 through 3 AP Micro, and this was set 1. All right, thanks for watching. See you guys next time.